Hello. So today I will discuss Chapter 8, Section 1. So Chapter 8 is about more applications of integration. Section 1 of Chapter 8 is called Arclength of a curve. So we have two cases that we're going to discuss. Case 1 is what you have in front of us. So the idea is that you'll be given a curve represented by y equals f of x, and that curve is going to be between point P and then point Q, which is basically the curve is over the given interval, the closed interval alpha to beta. So the question here to find how long is this arc length, how long is this curve, or this arc, or this piece of the curve. So that's the question. So we have a small proof here. The proof is this: we're going to take an arc of the curve starting from point O to point Q, and we're going to call the distance or the length of this arc as delta L. So this piece is given here. It may not be really close to each other, but it's still, this is OQ. And we're trying to find this length delta L. So the proof is going to go this way. From point O, we're going to draw a horizontal line. Then from point Q, we're going to draw a vertical line. The two lines will connect at a point we call P. And then this side, the side OP, is going to be called delta X, and the side PQ is going to be called delta Y. So then so this time, next is we're going to draw a line that will connect point O to point Q, such that it will give us this right triangle, because this is a right angle. So when you connect point O to point Q with a straight line, you'll get a right triangle where the sides are delta X, delta Y, and then the length, the side OQ bar. Notice that this side, the hypotenuse of this triangle, is smaller than delta L, because delta L is like there. So, but what you can say is we can estimate delta L with the hypotenuse OQ bar. So this way we're going to do the analysis on the right triangle, because we know about the right triangle. So we know by Pythagorean theorem, if you square delta X, you square delta Y, you add 2, is going to give you the hypotenuse squared, which is what you express here. So what does it mean? Because we have this estimation, delta L can be estimated with OQ bar. If we square both sides, we're going to get this. But we know the right side is actually delta X squared plus delta Y squared. So we can just replace the right side by delta X squared plus delta Y squared. And then we still get this estimate. Because delta X, as you can see, is a side, so it's positive. Delta Y is also another side of the triangle. They are both positive. So it's going to be okay to divide this estimation by delta X squared. So when we divide that, you can see we have delta X squared divided by delta X squared is 1. So from here, we go back to the property of a precalculus. We know you can express m over n all squared by m squared over n squared. So that's why we can change delta x squared over delta L squared over delta x squared by delta L over delta x all squared. Do the same thing here. We get delta y over delta x all squared. But then we go back to all of these. When we're using delta, we're thinking of a Riemann sum. So by Riemann sum, when you let delta x go to 0, that means delta L over delta x will become dL over dx. D stands for derivative. And delta y over delta x will become dy over dx. And the estimation will become equal sign. Just by Riemann, so we're going from, we use Riemann sum. We let delta x go to 0, then all of those are true. So from here, we can take the square root of both sides of the equation. Since we're talking about the distances, we only take the plus sign. Instead of plus or minus, we just take the positive because the length is assumed to be positive. So we get delta L over delta x equals square root of 1 plus dy dx squared. Then we get, so from here, since dx is a differential, we can multiply both sides by dx, and then we get dl equals the square root of 1 plus dy over dx squared dx. So this is what we call the Arclength differential or Arclength element. Now when you take the integral of the Arclength element, since d stands for derivative, you'll get L. And since our Arclength is over the interval alpha and beta, so when you integrate, we're going to integrate from alpha to beta. And we get the formula for the Arclength of a curve y equals f of x on the interval alpha comma beta. So this is the formula for the Arclength. Notation, sometimes dy dx is called y prime. So if you replace this by y prime, you get y prime squared here. So sometimes y prime is also called f prime of x. So you get f prime of x squared. So you have the three versions of the formula, but it means the same thing. So that is the formula for the Arclength. So now let's go by an example. The first example is to find the length of the curve y equals 1 plus 6x raised to 3/2 on the interval 0, 1. So we know the formula is going to be L equals the integral from alpha to beta of the square root of 1 plus y prime squared dx. So what we need to do is take the derivative of y. Our y is 1 plus 6x raised to 3/2. When you take the derivative, the derivative of 1 is 0. The derivative of 6 times x to 3/2 is basically 6 times 3/2, and then times x raised to 3/2 minus 1. We use what we call the power rule of derivative. We simplify 2, we end up with 3 times 3, which is 9, and then a 3/2 minus 1 is a half. So this is y prime. The formula says to square y prime. So we square y prime, we get, when you square 9, you get 81. When you square x raised to a half, you get x. And the formula says to add 1 to the result. So we add 1. We get 1 plus 81x. And then we take the square root. Take the square root of that. We get the square root of 1 plus 81x. 0 to 1 means, the interval 0, 1 means alpha is 0 and then beta is 1. So we say that L equals the integral from 0 to 1 of a square root of 1 plus 81x dx. So we let u be 1 plus 81x. Because this integral now, we can do it by the substitution, integration by substitution. U equals 1 plus 81 dx. So that when x is 0, u is 1. When x is 1, u is 82. Because we want to change this integral to a u integral. So u is 1 over 81x, so du is 81 dx. So that means dx is a du over 81. So we go and plug in all the data. X equals 0 corresponds to u equals 1. X equals 1 corresponds to u equals 81. The square root of u is 1 plus 81x, and then dx is a du over 81. So we have the u integral, and then we can bring 1 over 81 outside because it's a number, and we integrate from 1 to 81. We're going to integrate u raised to a half, but then we use the power rule of integration. When you integrate u raised to a half, it becomes u raised to a half plus 1 over a half plus 1. And then we're going to evaluate this as 182. So we add, and we divide by, when you divide them by a fraction, you flip or multiply, so you get 2/3. And then you plug in 82 first, and then 1 second, and then you take the derivative, then you take the difference. And then you get the 2 over 243 times 81 raised to 3 halves can also be written as 82 raised to 3 halves can be written as 82 times square root of 82 minus 1. And we stop here. Thank you.